So good morning to all again. Let me share the file now. So here this is just introduction. We don't want much information. This we just want they will ask 3 marks question. What is the effective mass? So effective mass, you need to know what is effective mass, when it should be appear. That's what you have to know. So I don't want to explain much, but effective mass is not equal to the original mass of the particle. It's completely different. So generally we know this normal mass of electron is normal mass. Let me. So normal mass, we know that m of the electron, right? We write it sometime me is equal to 9.1 into 10 to the power of minus 31 kgs. But m star is indicates effective mass of the uh, so you should remember like this. This is the effective mass of the. So this formula very important beta. So effective mass of the electron can depend on the energy levels of the lattice. So what is this? This is a dispersion relation. D square E by dk square is the dispersion relation. How the electron see the potential when it's moving in the lattice. So as you all know, this lattice has atoms, right? So each atom, there are many electron depends upon the type of crystal, and when electron is moving or when electron is seeing this site, definitely it has some kind of like a potential well, infinite well. So though based on that, so we discuss the effective mass comes only when electron see the potential of a crystal lattice. Is it clear? Effective mass can play important role in case of crystals. You can have the effective mass only when electron sees the potential of the lattice. Okay, that's good. Then here what is the energy? The energy of the, this is according to the quantum mechanics, E is equals to h cross omega, where h cross equal to h by 2 pi and h is equals to Planck constant. And these are the very important to remember. And here is frequency. Okay, so E is equal to h cross omega indicates energy. This is the energy, quantum energy levels. Okay, sometimes we write it as nh cross omega also, where n is equal to 1, 2, etc. And there is a there is a energy called according to quantum mechanics, there is a term 1 n by 2 h cross omega. Here you should take it as a 0, 1, 2, etc. So when you take 0, you're gonna get half h cross. Okay, even at 0 ground state, n 0 1 2, that means ground state. Even at ground state also you have the energy of h cross omega. Okay, that's clear. Then and here I am showing here uh, what is the group velocity and phase velocity. Phase velocity is simply W by K. This is a very important bit for competitive exams. What is the phase velocity? It is a ratio of the angular frequency to the angular vector, wave vector. This is called wave vector. This is angular frequency. But when it's coming to the group velocity, this is single wave velocity beta, phase velocity. How the particle moving in a wave indicates phase velocity. Like you have the number of particles in the wave, right? What is the difference? How the wave is propagating, that gives the phase velocity. And group velocity indicate group of waves. Group of waves. What is the velocity of the group of waves? That is given by d omega by, you should remember, this is also very important geometry entrance, d omega by dk. This is called group velocity. Okay, that's good. Then moving into the what I want to tell. So, what is the velocity? Normal velocity, you all know that normal velocity is a rate of change of, sorry, normal acceleration is rate of change of velocity. And velocity is equal to rate of change of displacement. We all know this is from the school level. Okay. And here I'm trying to explain that. So what is this? Acceleration is a particle, acceleration of a particle is given by time derivative of its velocity. Like you are derivating velocity with respect to time. If you want velocity, you have to derivate the like a displacement with respect to time. Okay. And then here you can see this. Okay, let me bring that here. So I want to, so what is here? I just want to understand here what I'm, this is acceleration beta. Acceleration of a particle is given by this. So acceleration is equal to what we know, that rate of change of velocity dv by dt, but here I'm taking a group velocity. So when I write it d by dt, what is velocity? We got it just group velocity d omega by dk. Rate of change of it's not a rate of change of, it is a ratio of the, it is a ratio of the angular frequency to the wave vector difference. Okay, so this is called wave. So you just substitute here wherever you have the vg. Remember that important bit. So you just need to substitute it. Okay, then here see what I try to change it here. So from here to here, how I got it, you should understand. So what I'm taking here, this one I am writing as a dk. This one I'm bringing here dk. The remaining I am writing here. So what I then remaining, what is there? Let me keep it here. So how I got it? So d by dk, then d omega by dk, dk by dt. So I'm multiplying and dividing by dk here. So let me write it here. D by dk and d omega by dk and dk by dt. Sir, what you're drawing, sir? We didn't understand here. So let me clarify that. So from here, what I try to do here, I'm multiplying and dividing by dk. So when I cancel it, I'm going to get back here. This is what I have to get it. Dk cancel, d omega by dt is there, right? So I'm just readjusting to get something. Is it clear? D by dt, I brought this dt in the dk by dt. Okay, and dk, when I divide and multiply by dk, I just wrote like a d by dk, d omega by dk and dk by dt. So that is fine. So you should understand this, how I got that one. Then now you should tell me here what I got it here. So here I got something here. D by dk I wrote it. So what is the omega? Tell me. What is the omega? So what is the k? What is the omega? We should tell it. So we know that E is equal to h cross omega. This is what energy, right? So now I have to get it here. D omega by dk. D omega by dk. Or I can write it as a k is equal to this. K is equal to this. If I do that, what I'm going to get, omega is how much, tell me. So here, in both equation, I have to, I got it h cross omega. K is how much? H cross omega. I'm writing, this is a kinetic energy term here. So I'm H cross K and H cross omega. Here what I got it, tell me, d omega by dk. D omega, how much I can get it, tell me. So d omega I got it, dk is equal to, de is equal to, or dk is equal to h cross d omega. So I'm just writing here. Then you can see here, here 1 by so h cross, you can d omega, I want it. If I want to d omega, what happen? H cross goes down. This you can k by h cross is equal to d omega dk. You can write it like this. So that is, see here, 1 h cross come here. So when I substitute here d omega, I got 1 h cross down. Okay. When I do here also dk by dt, and then I one more h cut I can get it here. ఇక్కడ ఒకటి వస్తుంది. సో అప్పుడేం వస్తుందంటే, సింపుల్గా మీకు చెప్పాలంటే హెచ్ క్రాస్ తోని ఇంటూ మల్టిప్లై చేస్తే కూడా వస్తుంది బెట. ఇక్కడ ఏం చేయండి అంటే, ఇంకొక సింపుల్గా చెప్తాను మీకు. What I'm just re-explain that. So what you do here is simply, what you do, you this is actually, you just multiply h cross here and here. Okay. And when you multiply 2 times h cross, you have to divide h cross. This is easy method, beta. This is easy method. So let me clear it again. I'll tell the Thirmal Reddy sir to take little more time in later class, because I had to complete this. From here, what I am trying to say, you can dk. What I am doing here is, I'm just multiplying h cross here, d omega. I'm trying to multiply h cross here, h cross omega by dk. Then again here also I'm trying to multiply h cross k by dt. So I multiply 2 times here, so 1 by h cross, I'm squaring it. Okay, is it clear, Sushma?
Yes sir.
2 times I multiplied here. ఇక్కడ 2 సార్లు చేశాను కాబట్టి కింద డివైడ్ అయిపోయింది.
Okay sir.
So I got a 1 by h cross square. Then what I have it now? So now I have to do it. I have to get this. So last one I did. So h cross omega. What I have to do here? So d by dk h cross omega. From here, d by dk of that. D by dk of that. Why I don't need to write this one? Yeah. I don't need to write this one. Yes, simply d by dk. Oh, it's there, right? D by dk is there. D by dk is there. H cross omega. Yes, here also there. And this is another one. Yeah. So now it's, how do we get this one is the question. So how do we get this one? 1 by h cross square. Okay. So we have the E is equal to h cross omega. Okay. Then from here, you should know that V is equal to omega by k. K is equal to, yeah, this part actually, you're gonna get this one, d square E by dk square. So what is this actually? H cross omega is energy, right? Is it clear? What is H cross omega, beta? E,
Energy.
right? E,
Energy.
right?
Yes, sir.
So d by dk of d by dk. Okay. Then d by dt of h cross k. Note down. So now again there is a, I can write it as a d into d square, right? 1 by h cross square d square e by dk square. Then d by dt of h cross k by, yeah. So did you understand this? Yes?
Yes, sir.
Kind of little, stuff that we have to do it. But, it's very important when you're going for higher education, you should know this stuff. So now you can think about, now there is a term is given here. So what is that? So this is the term we are looking. So 1 by, so here we can think about this. What is this? Tell me. Okay. What is this? So here m star we already noted that h cross square by d h square, what is this? D square e by dk square, right? You just need to substitute here. So what we are going to get, uh, 1 by m this. So from here, this is equal to what? From here, h cross, so you need to substitute this. Here, 1 by, uh, so what are you going to get? Tell me here. In this term, this indicates effective mass. Effective mass. Okay. So I think this is enough for the, effective mass. I don't want to spend much on this because we don't need much. Okay. Is it clear?
Yes, sir.
So effective, what is the, let me ask few points, because if someone like 4 marks question they ask, effective mass is not equal to the original mass of the particle, right? First point. The second point is effective mass can play own role only in case of crystal lattice. When the electron sees the potential in a crystal lattice, you have the effective mass. So effective mass can depend on the energy, right? Dispersion relation of energy d square E by dk square. It also depends on the Planck constant, right? And the equation for effective mass is equal to h square by d square by dk. If you write these 4 points, you're going to get 4 marks. Okay. Is it clear?
Yes, sir.
Right. I'm going to clear it. But yeah, I don't think you need lot of equations. This is enough. There are a lot of stuff is there, but I don't think you need all this stuff. I think doing work on the electron increases. Doing work on the electron increases in energy, that's correct. All this work done, again you get some relation for work done. But I don't think that's fine, I guess. Yeah, I mean, this is equation. F is equal to ma, right? So m is different than this m. So actually we write it as 1 by m is equal to m. So you have to remember this normal Newton equation is F is equal to ma, but that mass is different than this effective mass. You should remember that. So the electron is subjected to internal force from the lattice ions like a core electron. So external force such as electric field, which actually makes the electron to move in a crystal lattice so that it gets the effective mass. So this is the hole can be understand as the electron with negative effective mass. So you should remember here the hole can be understand. What is a hole? So in the absence of electron, we call it as a hole, right? Hole is nothing but positive ion, right? Hole is nothing but positive ion. When electron move from the conduction band, valency band to the conduction band. So as you know this, I mean, so whenever it moves like it's a valency band, conduction band, this is the energy. So when electron jumps from here you can you have created a hole, and here electrons are plenty of electrons are there which are free. Okay, and now the energy spectrum you can see is very important diagram for the energy spectrum. And see this energy versus wave vector graph, and these are the energy uh, band gaps, energy gaps. So allowed energy and there's forbidden energy gap. There are some energies are allowed, some are forbidden. So negatively charged particle with negative mass will be accelerated like a positive particle. So negatively, you can hear negatively charged particle, they are joining now. See, so very bad. I don't know why they are joining now. Negatively charged particle will negative mass will be accelerated like a positive particle. Okay. So without crystal lattice, the hole cannot exist. Remember, guys, this is also very important. What is a hole? Hole is nothing but positively charged, but without crystal lattice, there is no hole exist. Okay, hole cannot exist. Okay, it is a basically positive charge particle, and here you can see that, and there is a brilliant zones beta. This is the brilliant zone, first brilliant zone, where you this is the energy is allowed, here not allowed, first brilliant zone. Okay, and this is graph is very important to remember for competitive exam. Simply which of the following option is correct for the first brilliant zones, you have the only like this. Okay, and pi by 4 minus pi by 4 nana here, pi by a, sorry, a is the lattice constant. Here you can see the valence band and conduction band, and this is the energy gap. Okay, then you have the generation of, as you all know, the generation of when electron jumps from here to here, there is a recombination of electron hole pairs that is there. And non-cubic, like cubic crystals are there, and these are the allowed energy bands, forbidden bands. And this is the energy spectrum. You don't need much, but with this only we calculate the crystal structure. I mean, band structure is band theory play very important role in determination in determining the crystal structures. Like gold undi gaani diamond undi gaani, shaped structure మనము కనుక్కోవాలంటే we need to know this all this stuff. But anyway, you are not going to work on this. You don't need much information. This is only for research purpose. But anyway, thank you so much. I think we completed this chapter. For now, we're going to move for the next the chapter which we call it as a you know last chapter, superconductivity, which is really exciting, beta. So really, really great chapter to begin. Ask your friend to join, which is again 20 marks weightage. A last chapter. If you can prepare that also, it's enough to get at least pass. You know, ask everybody to join that. And especially that's a very interesting chapter too. What is conductivity? What is superconductivity? And as you know that magnetic levitation, the trains, the bullet trains, you might have heard the bullet trains, how they go faster, like 800 kilometers per hour. So that is the bullet train, and that can be working under the only principle of this magnetic levitation and superconductivity behavior. We are going to use that. Okay, so let me stop here. Sir, I'm in the class. Sir, class this. Yeah. uh, guys, I got a just call, and I think class is over. You can join the Tirumala Reddy sir class now. What's the time now? 10 o'clock, right?
Yes, sir.
So 10 o'clock you have the class or 10:15?
10 o'clock, sir.
10
10
o'clock.
o'clock, sir.
Okay, that's fine. But tomorrow, guys, tell again, once again, tell your friends again. Make it like a 30-35 members. At least last unit. I mean,
Yeah,
Monday, I'm not going to take class. Tomorrow and day after tomorrow, there will be a class on Monday, but that will be exam. Monday will be exam on this unit 3. We didn't even conduct the unit 2 also, but we'll have a exam. Whatever we discuss the unit 3, semiconductor, Hall effect, all this stuff, just go through it and we'll have a exam. Okay, na? Monday exam, okay, na?
Okay, sir.
Hmm.
Okay, sir.
Monday exam, I'll also post in the group.